Okay, we will start in 2 minutes. Hello? Hello? Okay, we'll start the class now. Welcome to BSc 136 Discrete Math. Is it a record? Okay. Okay, good. So I'm your lecturer this semester. My name is Seng. Everyone see it? Okay, so you can call me Seng. Yes, and I already posted the course information on Moodle. I hope you guys have access to the Moodle. Who haven't had access to the Moodle yet? You haven't had it? Okay, I got 19 students that I can't enroll them in yet because your student ID, I think, is not in the system yet. So if you can't access the Moodle, please email me after the class, okay? I'll check. And then some administrative announcement. So in the class, you should wear masks at all times. This is the university policy. I can take it off if I'm away from you. Is it okay? Am I speaking here? Okay. If I go close to you, then I will wear. And then so mask. Okay. And then also help switch off the aircon after use. Okay. And one important thing is attendance. So attendance have to be 80% and above so that you are allowed to enter the final exam hall to take the examination. Okay. Otherwise, you will fail the course. And I will pass down the attendance sheet later. Okay. Please sign. And then take care of it because I need to keep it for record for the whole semester, 15 weeks. Need the physical record. I'll pass it down later. And then 10 minutes rules. I think I'm not sure whether you have heard it from other lecturers or not. So before 10 minutes, you should enter the class, also me, to prepare, and then I will release you 10 minutes earlier. Okay? So that you can run to other classes if you need. What else? Okay. We got 5 quizzes in this semester, in class quizzes. So our class is 3 hours long. So it's 2 hours lecture plus 1 hour tutorial. Okay. I'll do it in the tutorial time for quizzes. And then the planning time I already put in the course information. You can check it out. And then first quiz should be happening on week 3. So be prepared. Okay. And I will post the lecture notes. And then the lecture notes I put on Moodle is from past year. It's for your reference. Either I will use it or I will do my own lecture notes. But every time after I present the lectures, I will upload my version of lecture notes. Okay. And I will put tutorial question every week before the week start, so you can try it out yourself. And there's a textbook we use. There's a textbook we use in this course. So let's see. I'll show you. Uh, did all of you see the textbook in the Moodle already? Yes. Okay. Then never mind. I'll show it later. So okay, and then final exam is the last week, and then we will do revision on the last week, and then what else? So okay, double pass rule. So you should pass all the coursework and then all the final 40 and above to pass this course. Okay. So that means your coursework include quizzes and mixed term and then final. So inside your coursework, you will see that this is 20%, this is 30%, this is 50%. So you need to pass 40% of this, 50%, and then 40% of this 40% to pass this course. And then you should have seen this table here. Let me move it up. So to pass the whole course, you need to be 55 and above. Okay. And then not enough to get 55 and above. You need to do 40 and above for your coursework, your quizzes, your midterm, and also your final. Is it clear? Any question? Okay, so please ask question in the lecture if you have any question. Just raise up your hand and ask. Okay. Okay. So what else? Okay, dictionaries are not allowed during examination. And I think I put my office hours. My office hours for the moment I put Wednesday and Thursday after the class is 2 to 2 p.m. 12 to 2 p.m. And my office is in Air 448. Okay. Yeah. And then my email address is just my first name and last name at smu.edu.mo. Same. Okay. These are all in the coursework course information. So during the lecture, I hope you're not just taking down the notes, but just listen what I say, and then try to understand what I say. Because after each lecture, I will put up the notes. Okay, you don't need to busy copying. What you need to do is to understand what I say. If you don't understand, raise your hand and ask. Okay. This mathematics course is maybe a bit different from what you learn when you study mathematics. This is a course to learn the language of mathematics. Okay, I believe all of you are in computer science, right? Okay, so um, this is the course where you learn how to define things, how to apply the definitions, how to use examples, how to see from examples, and then define abstract notion. Yeah. Any questions? Any questions? Okay. So I want to remind you again, in this course, we will have a lot of definitions. So soon after I define the definitions, I should give you examples to understand the definitions. Okay, and then we will do some application tutorial or examples. I already put out a few references for you online, so you all can check out those references. There are plenty of examples, exercises, maybe solution to exercises. If you try it yourself, you can bring it to the class to us. So maybe I set every lecture, the first maybe 15 to 20 minutes, you can ask your question, Q&A section. For example, now this period will turn into a Q&A section every week. Is that okay? So whatever question you collect, and then you bring it next week. At the start of the lecture, I will answer your question. Okay. Yeah. Is that okay? Okay. So this section, yeah. So this M&E will become a Q&A section. Okay. Any more questions? No more questions, then we will start the course. Okay. So first thing you learn in this course is called logic. Okay. First, to talk about logic, you need to say some meaningful sentences. Okay. So what are the sentences? So let's define what sentence is. Okay. So this sentence is a sentence is a complete statement formed according to the rules of grammar and communicating a meaningful thought. The sentence. Okay. For examples. Okay. Take for examples. So first example. Write this. Second example. Third example. And then fourth example. Okay, so first example, is this a sentence? Is this a sentence or not? No, right? Okay, because the grammar is wrong. Maybe I don't understand what you're talking about. Should you? Okay, how about second example? So this is one example. Second example? Hmm? Yes, right. Okay, this is the correct one. Okay, third example? Yes. Okay. Fourth example? What? Why is no? Why is it no? No? Yeah, okay. Maybe this okay, we will go into this later. This is called a true value. But if whether or not this is a sentence or not, this is a sentence. This is a proper sentence. Okay. It is a sentence. Okay. What you said just now will turn into next concept later. Okay. So what is true? Wait, let me write down. So this is a wait, let me, this is okay. This is a sentence. Okay. This is a sentence. It's false, but it's a sentence. Okay. So we will go into next concept. Then later we will address the truth value of a sentence. So what we want to define next is a proposition or a statement. Okay, both can. Proposition or statement, they refer to the same thing. If you see these two words, they refer to the same thing. So what is it? It is a declarative statement. Sentence, sorry, I define sentence. So sentence that is true or false, but not both. So in mathematics, we are interested in the sentence that we can say whether it is true or false. Okay, it's a declarative sentence. Okay, for example, okay, this is of course not a proposition anymore because it's not a sentence even. Who are you? Is it a proposition or not? No, right? Because I can't say it's true or false. Okay, so is Xiamen University located in Sepang? True, right? Okay. First of all, this is a proposition. First, and then this is true. Okay. Because you can check whether it's true or false. Okay, check on the Google map. So how about fourth question? Fourth example. So someone suggested this is false just now, right? So why is it false? So okay, 2 million. Okay. So in order to say a proposition is false, you need to come up with a counter example. Okay. This is the way you prove things. Later we will touch on it again. So the counter example is 2 million. Okay. Okay. Maybe remember to silent your phone. So one counter example is 2 million is greater than 1, but it's also greater than 1 million. Okay. So this is how you prove some statement is wrong. You just need to come up with an counter example. Okay. Okay, good. So we also don't like a statement that is both true and false. Okay, it's meaningless. We will touch on it again also later. Okay. Uh, yeah. So another remark is so we call this true and false the truth value. Okay, truth values. So the true value of a proposition is true if the proposition itself is true. Okay. And then it is false if the proposition itself is false. Okay. Okay. Go to the next one. So for these sentences, we will introduce some notation. So maybe we will use the small letters like, for example, P, Q, S, okay, to represent different proposition. And we will use capital letter E for true, and then F for false. Okay, we shall see later. So now we already have this proposition. We want to make new proposition out of these all propositions. Okay. So what are these called? So definition. So we call this a compound proposition. Okay. And this is a proposition. And then how do you make this proposition? So we use this use some logical operations such as negation, and or. Okay, so I haven't told you what is negation, and or. Okay, this and seems repetitive, but it's different and. Okay, this is a English and this is a logic and. Okay, so let's see. So let us introduce what is the negation here. Okay, so every time when I write down this definition, right, you should understand every word inside here. For example, now I didn't tell you negation, so you should ask me what is negation. Okay. So for every definition, you should understand every single nouns here. So for example, proposition, I already told you. It is a declarative sentence that is false, true or false, but not both. And then you should ask me what is sentence. So a sentence is this. And then you should ask me what is statement. But of course, we can't go all the way back because we have to start somewhere in the English. Okay. Okay, so I choose to start from this sentence here, and then make sure you say the right sentence, and then we can discuss whether your sentence is correct, is true or false. Okay, and then after that we build new proposition out of these old propositions called compound proposition. Okay, let's introduce what is negation of a proposition is. So let P be a proposition. Proposition. Okay. So what's the negation of P? Not P. Or someone say not P. You do homework, is it? So in order by, so usually we'll write like this, not P. Okay. Is the statement. So what's the statement? It is not the case that P. Okay. So example. So you should ask me example, okay? So example, let me copy the two statements here. Give back. What's the maybe to you seems like this is an English class, is it? Okay, never mind. So let me put it back here. Okay, so let me do something. So let P we define as this statement here. Okay. So we want to see what is not P. What is not P? Huh? Okay, it is not the case that, okay, let me use the copy function as option to be. Okay, let me copy the smaller one. So it's not the case that some university is located in the farm. Okay, there's another word. There's another in another word, you can say that SMUM is not located. Okay, from here, what you can see. So usually, if P is true, then not P is false. Okay, this is what you observe. Okay, and then what? Okay, yeah, later I will say again. Okay, next example. Let Q be this sentence here. So what's not Q? Huh? What's not Q? It is not the case that not the case that every number greater than 1, etc. Okay, in other words, is okay, not every number greater than 1. Okay, okay. You just reduce this to one sentence, but there's another way to say it is, okay, I will should I let me okay, wait, let me okay, maybe I write down what you say. Okay, let me write down what you said first. Let me move this out. Okay, I write down what you say, okay? Not every number. Not every number. Okay, there's another way to say it is that as this a number greater than 1, that is greater or equal to 1 million. Okay, so this we will touch it in the later subtopic, later part. This is called the quantifier. Okay, we will come back to this every that exists again later. Okay, so we come back to this negation thing. So remark. So we call this I'll try to write this. Call not P. Call not P, not P. Okay. Call not P, not P. And then usually we say not P. Okay. And then since this not P is a proposition, we can talk about the truth values. So the truth value of the negation of P is the opposite of the truth value P. So that means if P is true, not P will be false. If not P, if P is false, then not P will be true. Okay. So the next thing to tabulate this true value will be using what we call a truth table. So we can write a truth table for it. Okay. So what is a truth table? So truth table is a table that consists of all the possibilities, all the possible true values you can write for a proposition. Okay. Okay, so one of the learning outcome that you need to know um in this course is to know how to produce a truth table. This will be definitely in the exam, okay? Okay, so what's the truth table? So you got P, you got not P. Okay, not P, we have a few ways to write it. You can also write it in this way, like this, also not P, and also curly P. Okay, these are all not P. If you see in any literature. Okay, okay. So if so the truth table will include all the possibility of the proposition. So this P may be true or maybe false. So if P is true, then not P is false. If P is false, not P is. So this is the truth table for this negation of proposition. Okay. Any question? Okay. So next, so we need to introduce N and O, right? So N and O in the usual ordinary speech, you also use N and O to combine sentences, right? Similarly in logic. So for example, so let P and Q be a proposition. Okay. So N, we will call it the conjunction. So if you see a conjunction of two proposition, you should know that it's an N. And I'm not sure is this the proper computer science language. Okay. So, so usually we write P hat Q. Okay, P hat Q. P hat Q. So what is this? This is the proposition. Okay, since this is a proposition, later we can ask about the truth value also. So proposition, or what is this proposition? This is P and Q. Okay. So what's the true value? So it must be true only when both of them are true. Okay. It's true when both P Q are true, and it's false. It's false otherwise. Okay. So I'll write out the uh, truth table for you. P, Q, P, and Q. P hat Q. Okay. Okay. So P can be true Q can be true, P can be true, Q can be false, P can be false, Q can be true, P can be false, Q can be false. Okay, so these are all the possibilities. So the possibility is 2 to the power 2. Okay, 2 times 2 because P can be true or false, Q can be true or false. So they all got 2 to the 2 possibilities. So only true when both of them are true. So this is true, then the other is false. Okay. Okay, let me see. Let me see. Okay, so examples. So let me give examples. Let me give examples. Okay. So T, the durian from Q, the vinegar is sweet. Okay, so P and Q is true or false? False. Why? Because it's not sweet. Okay. Because let me write. False. Because vinegar is not sweet. But our okay. Although the durian is thorny, but the vinegar is not sweet. Okay, so P and Q is false. Okay, good. Okay, what time is it now? 4:45. Okay, so next. So let's define the next thing. So let me just copy this to it again. E. Okay, OR is a bit interesting. There's two kind of OR, okay? So we will do the first kind first. So the first OR is we call disjunction. Okay, disjunction. Similarly, we have two P and Q proposition. And then disjunction of P and Q will write P or Q. So it's an inverted hat. Okay, inverted hat. And then it's a proposition P or Q. Okay. So the disjunction. So you want to ask when is it true or when is it false? So P or Q is what? Is false only when both of them are false. Okay. So it's true otherwise. So all is more lenient. Okay. Either one of them is true. Okay, that's fine. It's true already. Okay. So I should write down the table for you to see. Please slow me down if you need. Okay. So just raise your hand and then ask question. So let's write down all the possibility. True, 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 false, false, true, false, false. Okay. So any one of them is true is fine. So true, true, true. But this both of them is false. Did I write something wrong? Okay, no. Okay. Yeah. Okay. So examples. Okay, maybe we just use the same example then. Let's just get one. Okay. So what about P or Q? True or false? Why? Because P is true, yes. because P is true. We just require one of them is true. Any questions? No? So far so good? Can follow? Easy? Easy. Okay. Oh, good. Very good. Easy. Good. Okay. Nice. So next. Okay. In English, you may not realize that you have two kind of OR. So I will say that this disjunction we say just now of P and Q is called the inclusive OR. Okay, because we say that if it is both true, it is also true. Okay, so it's inclusive. Okay, let me see. So the inclusive OR. Okay, and then so definition. We will define an exclusive OR. Okay. So let me copy back again. I don't want to repeat the unnecessary word. Okay. Okay. So we call this exclusive OR. Okay. Okay. So I add another word here. So this is inclusive OR. Okay. Don't be confused. So this is the exclusive OR. Okay. Of course, we have to introduce the new notation here. So we will put this all plus, okay, all plus. So here, this is a logic short form. So it is called X or R. Okay, you put an extra X in front of the or. Okay, this is called the. Okay, maybe I use another color so that you are not exclusive or. Okay, and then change this notation. Okay, so it is true when we have to change all these. When is it true? When exactly one of P and Q is true and is false otherwise. Okay. So how does the truth table looks like? Let me copy this truth table again. Okay. So this is a false. Okay. So you may wonder how useful is this? How useful is this? Why we need two or? Okay. Example. Okay. You could have chicken rice or the economic price in D6 for your dinner tonight. Okay, so can you eat both? Sometimes you can't, right? Unless you are a big eater. So most of the time you only can choose one. Okay, or maybe you are not satisfied. I will use all my bonuses to buy an unit in Bell Street or buy a Tesla. Okay. So sometimes you just have that many money to buy one stuff. Yeah, this is the exclusive of. There's something coming out, is it? Okay, let me remove it. Okay. Okay, make sense? Make sense? Okay, 5 more minutes, we will have a break. So every 1 hour, we will break maybe 10 minutes. Toilet break. Okay, 5 more minutes, we will break. So next. Okay. So definition. So this is a new definition again. So let P and Q be proposition again. The conditional statement P implies Q. P implies Q is the proposition if P then Q. Okay, if P then Q. So when is it true? So this okay, I don't want to repeat it. So it is true. Sorry, maybe use false is easier. It is false when P is true and Q is false. And true otherwise. Okay, let me see. Okay, good. So I'll change this. P implies Q. So it's false when P is true, and P is true, Q is false. Okay, so it's this one. Okay, P is true, Q is false. So this is the only place where it is false. Okay, and then the other is true. Okay, let's examine this truth table here. Okay, so if you have some true hypothesis and implying some true consequences, of course this is true, right? Of course, intuitively, okay, intuitively. But if you say that something is true, implies something is wrong, it's always wrong, okay? It's always wrong. No matter what is true at first, what you did is wrong, okay? But you start with a wrong thing, but what the thing you do is correct, is true, then it's true. Okay. So false can imply anything. So that means even if you start with a wrong hypothesis, you get your result, although it's correct. You actually didn't know whether your hypothesis is correct or wrong, even though you get the result correct. Okay. So this is the dangerous part. And false implies false is true. Okay. Anything wrong imply anything. Any question? No questions? So let's try some example. Okay, so if let's try example. If it rains today, then what? Then I use the old example. Okay, so this statement is true or false? True or false? Who say true? Who say true? Raise up your hand. Who say true? Raise up your hand. Huh? Only one. Raise up high. I can't see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9% say it's true. How about the others? True or false? Don't know. Why is it true? For those who say it's true, huh? Why is it true? Because Xiamen University is located in Sepang. So let's call this, let's call this P. Let's call this Q. Q is true. Okay. So since Q is true, check back the truth table. Since Q is true, I don't really care what is P. Yeah, it's always true. Okay. I don't need to check whether it rains or not today. Okay. Okay. Let me try another question. Okay, let's put a claim here. If it rains today, then I will bring an umbrella. Okay. So when is this statement true? Huh? No. No. When it rains, so what? Yeah, when I bring an umbrella, then the statement is true. Okay, right? Remember, I only care about what's happening in Q, not P. Okay. Also, if I don't bring an umbrella, when is it true? Huh? If it doesn't rain today. Okay? Make sense? Any question? No question? Okay, we will break for 10 minutes and then we'll come back, and then in the next hour we will sign the attendance sheet. Yeah. Yeah.
I can understand.
You can't understand this?
Yeah.
Which one? Which part?
For example, sentence, I think there must be some relationship between two sentences, then I can wrote it for or whether they or not.
Yeah.
It's here, it's always the
Yeah.
So why sentence?
You mean why this sentence is true?
Yeah.
Okay. Okay, I will answer this question, but next time I want you to ask in the class. You just raise your hand, ask in the class. Because I don't like students like when I ask they are okay, but they're not okay. You just raise out your hand and ask. I will answer in the class. Okay, next time you ask in the class. Okay, so I'll answer you. So you're asking me why this sentence is true? Is it correct? Okay. So to check whether or not this sentence is correct, you need to make sure what? Start from here. So if not correct, okay, I should say true. So to say that this statement is true, there's only three ways for it to be true. Whether or not the okay, I call
it true or false. Whether or not the P is true or false, we only make sure the Q is true and the five is true.
okay. This is only talking about these two parts. You also can have this statement be true when both of them are false. Okay, you get it? Don't get it?
就是说，它不管 Q 是它有两种，一个是 Q 只要是对的，它就是对的；还有一个是它两个都是错的，它就是对的。就是不需要去证明他们两个之间有不用证明他们之间有什么关系。 哦，就只要说我提供了两个事实，我保证它其中的 Q 是对的，或者说两个都是错的情况下，对就可以了，不管这两个事实之间有没有什么关系。对。
You want to check the connection between the two? Wait, no. I think that's a different story. That's what. I think you are asking another level of question. You are trying to prove the statement. We are not trying to prove the statement. We are just trying to say whether this proposition is true or false. We are not proving the statement.
She wants to know whether P and Q, whether there are some logic in it.
No.
就是它之间是没有逻辑关系的，不需要逻辑关系。就是它没有逻辑关系，它也是对的。但你不能说它不是。
Maybe you can understand that. But we are not trying to prove anything. Yeah. I haven't proved
So,
that.
how to choose Q or P?
What do you mean?
Which one is Q? Which one is Q? The sentence then after the word then is Q.
Yeah.
Okay.
No, yeah. I mean, yeah. Okay, like this. So you see, if this, then this. So if, and then this. Yeah.
The sentence after the word then is always Q.
Something like that. Yeah. Okay. Yeah. Later I will say more about other forms. Sometimes it's not just if then. Yeah. Okay. You get it? Okay.
Why this
Okay.
one
Cool.
is true? Because then I will.
No. I'm just asking when it is true. It's not necessarily true. I'm just ask when it is true. Question is when it is true.
Q is it didn't happen.
If Q didn't happen, if Q didn't happen, then it must be the case. So if this is true, but Q is false, then P must be false. So that this
will be true.
Yeah.
Okay. This is false and this is false and this is true.
Yeah.
Or this is true, and this is true.
Yes. Or this is false,
this is true, and this is true.
Yeah. So my question is when this is true.
So what is this?
This one? I thought I introduced.
How to read this?
How to read this? I also don't know how to read this. Maybe you just read so SO. Yeah. SO. Yeah. SO.
So between P and Q, it must be one is true and one is false, and the statement is true.
Yes, correct. Because like in the example, right? You can't eat two meals.
How the right is or it has a.
I choose to put, but it's okay. Yeah, I choose to put. Yeah.
Do you know how to say this?
Exclusive. Exclusive.
Exclusive.
Yeah, exclusive. Yeah, this is English.
Sure.
I'm not sure.
Okay, thank
Not
you.
sure.
Thank you.
Not sure about Chinese version.
The symbol is just plus the symbol.
Yeah. All plus, huh? Sorry. Yeah. Together. Yeah. This two. Yeah. This two. Yeah. Right. That's right. All plus. Yeah. In latest form.
Answer to your question.
Huh?
To page 4.
Page 4.
I think.
It's okay. I will put it up later. This one. You want to compare or?
Just now the example, the durian is. I can't see the words. What is the word?
Oh. Tony. Like a lot of tones. Yeah. Or you can't see the word. Okay.
What's the key to join the model?
What's the key? I didn't know. I need to check. I can't give you now. Can you email me?
Okay.
Yeah, you email me. I try add you in. If not, then I give you the key. And thank you. Okay. I'll do it after the class.
About this. How is P and Q? Both of them are true. So P not Q
It's false.
is false. Yeah. So only when one of them gets true.
Yeah.
Okay. Thank
Sometimes you can't do both together.
Okay.
What do you want to know? I will upload the course, the lecture note later. Are you in the Moodle already? Huh? Not yet. Not yet. You should email me later. I'll check for you. Okay. Yeah. Okay. Two. Yeah.
Could you say if this is correct?
What do you mean? Yeah, this is correct. Yeah. Yeah. I think so. Wait, let me check. Yeah. True. False. True. False. False. True. Yeah. Okay. Hello. Hello. Testing. One more minute. Can anyone please help close the door? The aircon is going away. Please help close the door. Okay, everyone back yet? Okay. One thing, I want you to ask question in the class. Don't come and ask me after the class, okay? I give you a chance in the class. Please ask question in the class. I don't want to say that when you are okay and then you are actually not okay and then come back and ask me again. Okay? Make sure when I ask, if you have any question in the class, make sure you just raise up your hand. Or anytime you just raise out your hand and then just call up. Say that it's too fast or you don't understand. Okay, I don't want to repeat it every time. And then for the Moodle, right, you have to check whether you are in the Moodle or not. Not everything in the previous lecture note I will cover. So just study based on what I gave in the class. And then some part I don't cover is because maybe it's like application. So you can read yourself. But for those tested area, I will tell you beforehand. Okay, don't worry. For other knowledge, you can read for your own sake. Okay, because in university, right, we can't cover everything. And then for prepare you to go to work or postdoc, you have to definitely study on your own. For us, we do research, we also have to read something that's not even in our area. Okay, this is how the uni life. Okay. And let's continue. Oh, actually, I have one administrative very important one. So for mid-sem, I plan to do it on week 8. So I plan it because that week is a foundation exam. So we got time after 3 o'clock. For now, I will choose Monday. So please go back and check your schedule. Again, week 8. We can do either day after 3 o'clock, maybe 3 to 5, 2 hours. I will choose Monday for now. If there's no objection between this week and next week, I will fix week 8. Because your class, because this course actually shared by 3 groups, so we have over 200 students who are taking the exam together. So I need to fix the time. So it's week 8, 3 p.m. to 5 p.m. 2 hours. I want to put Monday. Okay. So make sure you email me either this week or next week. I will see what is available and then we will decide again. So if you email me, you should say that which day you can't do, okay? You don't tell me every day you can't do, okay? Because it's a bit hard to find a schedule. So So if you really can clean up this day for me, then for the course one day, week 8, and the venue should be at link. Okay, the ground floor. If you see a lot of table there, is the place for exam. Anyone check out the date? Yeah, you know the date. What's the date? What is week 8 date? Let me see. Anyone check the date? Huh? 1, 2, 3, 4, 5, 6, 7, 8. 8. Is it 8? 8. Is it this one? Okay. 7. Oh yeah, 7. Right. Okay. Let's start at Monday. So 7. 7. Okay. 7-11. Okay. Good day. 7-11. Okay. Okay. Make sure you clean out this day. Otherwise, you maybe email me and we will see how. Otherwise, we will fix Monday. Okay. Time. We won't change the time because that's available. You don't want to do. You want to do it in evening or not? No one. Okay. This one is the best time. Okay. Let me know again. We will confirm in next week, this week, next week, week 1, week 2. Okay. Week 1, week 2, week 2. Okay. Let's come back to this P implied Q business again. So actually, there are a few ways to say it. Oh shit, sorry. Let me come back again. Let me come back. Okay, good that you call me out. Otherwise, I do it for 1 hour here. Okay, so there are a few ways to say if P then Q, okay? Okay. So if P then Q. What we can do is if P, Q. Okay. If something happens, then another thing happens. Or Q happens if P. Okay. Maybe I put this instead of equal. Save the equal for the equation. So maybe I just put too many later. Okay. What else? I always say P implies Q. Okay. Because I'm trained under pure maths, so I do pure maths proving stuff. This is the first time I taught this course in a computer science context. So I also have to learn from you guys in a more applied sense. So whenever we say if P then Q, we always think that P implies Q. So we always think that there's a connection between P and Q. P happens first, then only Q happens. P implies Q. Okay. Or we can say P only if Q. Okay. Okay. What else? So in this case, P is for a sufficient condition for Q. So P is sufficient for Q to happen. Okay. Also, another way is Q is a necessary condition for P. So Q have to P have to happen. Q have to happen. Or we can say Q provided that P. Or Q whenever P. Yeah, whenever is like if. Okay, any question? Okay, don't busy copying down, okay? You need to understand what I'm saying because I will post this lecture notes later. No worries. No more question? No more question, we'll go into new notion. Huh? No? Okay, good. So next, we will say a converse. A converse of P implies Q is the proposition Q implies P. Okay, I hope you guys don't confuse again. So what do I mean by that? If I change this to R and S, and this I will change it to S to R. So what is important here is you need to notice that how this relative position change. Okay, the converse of P implies Q is to swap this Q and P. Okay, the converse. Okay, so you don't memorize this PQ thing. Okay, this PQ is just some abstract. You should replace this PQ with something else. And then what you should memorize is what the converse did to this P implies and Q. P implies Q. So you change it to Q implies P. So it's swap. Okay. Okay. Next one. Inverse. The next one is contrapositive. Oh, this is very interesting. Okay. This is, we always deal with this because later you will see that P implies Q is actually logically equivalent to not Q implies not P. Okay, so what you do is you swap it and then you not both of them. Okay. P implies Q, the contrapositive is not Q implies not P. Swap and then not negate both statements. This is the contrapositive. This is very useful in proving stuff. Because if you can't figure out how to prove P implies Q, the other direction you can prove is not Q implies not P. And later we will see that why these two are actually logically equivalent. Okay, later we'll see. Not sure it's later or later in the course. Not too far away. The last one you should know is the inverse. Okay, inverse. Inverse of P implies Q is the proposition. What's the proposition? Not P implies not Q. Okay, you just put not on both of them. Okay, see a difference or not? Not, just not on both of them. Okay, so usually, okay, I want to put aside here. So since I'm doing research on algebra, so this inverse is very close to me. So something we call it an inverse is when you do it, you compose it again, you get back identity. Okay, let me show you. Let me show you again. Let me show you. Maybe you blur again. You blur. Okay, let me show you again. So see, P implies Q. Okay, I do inverse on this thing. Inverse it. P implies Q. Become what? Become what? Huh? Not P imply? Imply not Q. Okay, very good. I do inverse again. What do you get? P implies Q. Very good. You see, when you do twice, you come back to yourself. So this is inverse. Alright, this is called inverse. That's why it is called inverse. Okay, converse is something backward, and then contrapositive is contrapositive. Any questions? Any questions? No question? Let you digest and then no question, we will go to the next one. Any question? No question? No question? Okay, go to the next one. Or you need example or not? You want example? For examples, okay. You want examples? Okay, you want examples. Let me do this example. And do this example. Okay, do this. Okay, let me put it here. And then maybe just copy this to remind you the definition. Yes. Okay. Okay, good. So example. Okay, so I want to let this be the so let me set it if P and Q. So in this case, P is it rains today, Q is I will bring an umbrella. Okay. So let me call this what? Call this R. Okay, let me move it. Call this R, okay? Call this R. R. So what's the converse of R? If I bring an umbrella, it will rain today. Wait, let me see. Umbrella. Then it will rain today. Okay, so what's the contrapositive? If I don't bring an umbrella, then what? Then, wow, you are very poor. It will not rain today. Okay, good. So what's the inverse? Hmm? If it I can't hear anything. If it doesn't rain, then I won't bring an umbrella. Wow, very good, good grammar, good grammar. Okay, very good grammar. I think this one is the English class. No, class. Okay, only for this few weeks. Okay, next few weeks you will do some counting. Okay, cool, very good. Any question from here? No questions. Okay, going on. Okay, so what is the use of this converse? Okay, now we will define another thing called a biconditional. Okay, if and only if. So let me copy this. Maybe I just copy everything across. Okay, don't busy copying. Think about what I teach, and then if you don't understand the idea, you should ask in the class. Use the time to digest what I say. Okay, let me remove this. Let me remove this. Remove this. Remove this. And then remove this. Remove this. Okay, start. So I want to introduce biconditional statement. Okay, the biconditional statement is what? I will draw the double-headed arrow, okay? Double-headed is the proposition. What is that proposition? P if and only if Q. Okay, so you should ask me, when is this true? Okay, when is this true? The biconditional. You also can guess when is it true. So it's true when both of them have the same true value. And is false otherwise. Okay, let's see what happened here. So it is only true when P and Q have the same true value. So either both of them are true, either both of them are false. So both of them are true is true, both of them are false is true. True, false, 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 true, false. Okay. So one headed and then the other headed. So it's like combined. Yeah. Usually when we prove this kind of statement, one direction is easier than the other direction. And only if. Sometimes we will just write FF. Okay. Some aside here, maybe just put aside here. Usually this not n or XO if then uh, if only if are called logical operators. Some would call only call these logical operators, some group include this. But anyway, as long as they are used to build new sentence, we call it logical operators. And then these two will call like this. Yeah. Not very important, but just for your knowledge. Okay, we still got time. Keep going, keep going. Any question? Any question on if and only if? You want examples to create your own example? You want examples or not? Ah, yes. You want examples? Do you have an example? Okay. Let me. Okay. Let's do example. Actually, it's quite interesting. Maybe. So, what do you have example in your mind or not? Or you want me to give example? What example is interesting? Any examples? Any examples? What kind of example? Let me just use this. Okay, the example is when is this true? When is this true? When? Huh? Both of them are true. That means if it rains today, and also I will bring an umbrella, then this is true. Yeah. Any more? Both of them are false. So if it doesn't rain today, if I don't bring an umbrella, then this proposition is also true. Okay. It's only false when only one of them doesn't achieve. It's not achieved, then it's false. Okay. No question? No question. We will keep going on again. Okay, we're going to a logic circuit. So this is the world of binary world. So your computer now is a binary world, okay? The binary digit. Let me write it down first. Let's talk about this a bit more. So let's go into a binary world. So binary world is what? Bit, binary digit. Only 0 and 1, 1, 0, 0, 1, 0, 1, 0, 1. If you got see the video before. 0, 1, 0, 1, 0, 1. Okay? So for now, your computer are built up from built up from a binary world, digit. Actually, currently they are researching on quantum computing, which is qubit. So now you are bit, right? Let me see. Okay, let me define bit first, and then I talk a bit about qubit. So bit. So what's a bit? Bit is a symbol with two possible values, namely 0 and 1. Okay. So how this bit come from? It's actually binary and digit. Binary bit. Yeah, bit. So now in this world, they are researching on qubit. So what's qubit? Qubit, the Q stands for quantum bit. So quantum bit is like 1 to 9. Think 0 to 9. 0 to 9. So you can store such many possibility. So that's why they say that maybe quantum computer is faster. Not maybe, it's actually faster than the computer now. Because it can store more information instead of just 0, 1, 0, 1, 0. Okay. You can store 0 up to 9 in one slot. Okay. Okay, that's our topic, but this is the current world. So if you're doing AI or something like that. Okay. So usually usually 0 is false and 1 mean true. So in this way you can turn all the or and XOR into this language. Okay. Or not also. Okay. Notice that you see I use a capital letter here. So this or and so not should be working on 0 and 1. These correspond to the small or small n XOR in the proposition world. So for example, okay. For example, the table will become like this. So table will become like this. So P, Q, P, and Q will become 1, 1, 1, 1, 0, 0, 0, 1, 0, and then 0, 0, 0. Okay. So let's check whether it's true or not. So what's P and Q? It's only true when both of them are true. So both of them are true, true. One true, one false, false. One false, one true, false. One false, one false, false. Okay. Okay, that's another way to do this. Okay, another one is just some easy calculus. So let us introduce a bit string. Okay, this is what I talked about just now. So a big string is a sequence of 0 or more bits. Okay, I will show you what it means soon. And the length of this string is the number of bits in the string. Okay, no place. String. Okay, example. So 10010001. So what's the length of this string? 7. I haven't counted. 1, 2, 3, 4, 5, 6, 7. Okay, good. So the length of the string is 7. Okay, very easy, right? Easy calculation. Okay, so next, just switching some language to the binary world. So we will call the bitwise OR. Let me see. So bitwise OR, and then bitwise and oh, this is a bit different. Okay, bitwise XOR respectively of 2 string. This is teach you how to add up 2 string. Okay. So you only can add out the string if they are the same length. Okay. Is the string that has of the corresponding bit in 2 string. So you only can add 2 string together. I mean, 2 string with same length. Yeah, this is very important. If they are not the same length, you can't really add them together. Okay, let's do some example. Okay, find bitwise. Okay, maybe I short form. So 10010110. Okay, let us do bitwise. Bitwise. Oh, you know how to do or not? So let's see this example. So it's a string that has 8 bits or of the corresponding bits. Okay, so that means add here, add here, add here, add here. Okay. Okay, so 1, 0 is what? 1. Or when is it all true? Either one of them is true, right? So 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. Or maybe I add few more number to check whether you know or not. 0, 0. Huh? 0. 1, 1, 1. Okay. So you are doing the truth table every bit. Okay. Let's do another one. So bitwise n. Okay, let's use the same number. Okay, 0, 0, 0, 0, 0, 1. Okay, 1, 1, 1, 0, 0, 1, 0, 1, 0, 0. Okay, 0 because it's n. Okay, 0, 1, 0, 0, 1, 1, 0. Okay, very good. Okay, do last one. This y xo 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1. Okay, 1, 1, 1, 1, 0, right? Okay, you don't have so many money to buy both things. 0, 0, 0, 0, so 0. 1, 0, 0, 1, 0, 1, 1, 0. Okay, good. Any question? Any questions? Very easy, huh? Later don't come back and ask me again. Quick, half an hour. No questions? Okay, let's go on. Let's go on. Okay, let's go on. Okay, actually, we got a diagram for this. Maybe you guys have seen it in your physics class or somewhere else. I'm not sure. But at least for me, I see it in my physics. So, a logic circuit. What's the logic circuit? So, logic circuit will receive input, this 0, 0, 1 thing. Okay, each a bit. And produce 0, 0, or 1. Again, depend on the signal. I mean, depend on the circuit. So I will draw for you what kind of circuit you would have later, okay? This is just another language. Maybe I can turn the question into this language and ask you. Okay, so make sure you are familiar here as well. So what kind of circuit could you have? You could have the not gate. Okay, the gate, logic gate. These are all the logic gate. Not gate, or we call it an inverter. So inverted inverter. So logic gate. Oh, how to draw it? Okay, you draw a triangle first. Okay, draw a triangle first, and then you draw a circle. Okay, and then output. So if you input a P, what do you get? It's a not get. What do you get? Huh? Not P. Very good. Because it's a not get. So if I draw a O gate, how many arrows should I have going in? How many? 2. Okay, at least 2. So 2, just 2, maybe something like this. Rocket, I'm getting. Maybe you need to check back your textbook. I think it's like this. Okay, so P, Q, what do you get? P or Q, very good. P or Q, P or Q. Okay, good. The next one is the AND gate. AND gate. Okay, AND gate. So AND gate, okay, how to draw AND gate? AND gate is the straight one. The straight one. Sorry if I'm not straight. Okay. So if I input P and Q, what do you get? P and Q. P and Q, very good. Okay. Let's spend about 20 minutes. Let's see what we can do. Maybe I will go a bit into the logical equivalence today. Okay, any question up to now? So we have introduced or, not, and, or, if then, if and only if, and then turn the first few logical operators into a Boolean language. These are called Boolean language. So later we will come back again in the last topic. We will come back to Boolean algebra again. So not very important for now. But what is important is you know how to manipulate the proposition. How to, if I give you a negation, how you turn it, how you negate a statement, how you combine the statement, how you decide whether a statement is true or false. Okay, you must know. Any questions? No questions? We will go into the next topic. So the next subtopic is logical equivalence. This is the part where you will know that why P implies Q is equivalent to its contrapositive. Okay, actually, there's one point I want to point out here. So you see, you learn about the converse of P implies Q, right? So what is P if and only if Q is actually P implies Q combined with the converse. Okay, so in mathematics, we will always, when we know that P implies Q, we will ask whether it converse is true or not. Because we want to know whether if I can go from P to Q, can I come back from Q to P? So are they the same? Because in mathematics, we care about equivalences. We want to know whether these two things are the same. So we will ask whether the converse is true or not. If the converse is true, if P implies Q is true, if the converse is also true, then P if and only Q. Okay. Okay. Okay, never mind. Right. Let's go. So what we will do is, okay, so first thing first, tautology. A tautology is a compound statement that is always true, no matter what the proof values of the proposition that occurs in it. Okay, so tautology is like it's always correct. It's always correct. So for example, you might think what is such kind of examples, okay? He he is tall or short. Okay, this is always correct, right? He is either tall or short. Is it? Huh? But he's either tall or short, right? One of the correct, then this statement is correct. Okay, so this statement is always correct. Okay, another thing is contradiction. Definition. So a contradiction is the opposite thing. So it's a proposition that is always false, no matter what you put. Okay. So for example, he is tall and short. He can only be tall or short. Okay. If it is not short, then this. If it's not tall, this is wrong. So either one it will happen. So this is always false. This statement. Okay. So don't say sometimes tautology is meaningless, sometimes it's not, sometimes it's meaningless. Sometimes contradiction also meaningless. Yeah. Okay. So you see, so example. So let me show, not show you, but in general, yeah, in general. Let me see what's the time now. Okay. Let me do one exercise. So use truth table to show that, okay, this is one of the skill you need to master, okay. P or not P is a tautology, and 2P and not P is a contradiction. Okay, so this is general. I replace P, the short and tall thing with general P. Okay, so you want me to show you? Want me to show you how to prove this? Huh? Yes or no? Yes. Yes. Yes or no? Okay, good. Okay, let's do show that P, what? This one is P. P or not P is tautology. Okay, so this kind of proof question, first of all, you want to show something. See, this is a proposition. Okay, this is a proposition. So you want to show that something is true now. Okay, so first of all, you want to prove something is true. You need to know what you are proving. What you are trying to prove. Okay, you are trying to prove this proposition is a tautology. So you need to go back and check what are these. What are these? So P or not P, you already understand, right? With the truth table. But what's the tautology? Means. Okay. I just defined 1 minute ago, maybe 2 minutes. A tautology is a compound proposition that's always true, no matter what true value you give. Okay. Let me draw this truth table first. Okay, let me put in all the necessary proposition. P, wait, P, not P, and then P or not P. Okay. So what is your goal? Your goal is to prove that P or not P is what? Is what? Is what? It's always true. It's tautology. The definition to show that tautology is to show the proposition is always true. So there's only true can appear in this column. If there's false here, then it's not tautology anymore. Okay? So let's see what happened. How many choice you have for P? 2 choice, right? Either true or false. So you got true or false. If P is true, not P is false. If P is false, not P is true. So P is true, not P is false. P or not P is true. P is false, not P is true. P or not P is true. So there's only true here, and I already checked all the possibility. Okay. Of course, you say that maybe this example looks easy, right? So you need to how to say really learn the method. And then try out the question behind the textbook. Maybe sometime I'll give it in the tutorial, but maybe I can't cover so many things in the tutorial. So you should do it on your own time. And then if you have questions, like what I said, every start of the lecture, you can ask questions. Okay, free ask, who first come first serve. So everything, everybody will benefit from it. Okay. Hey, I forget this. So please take out of it and then sign, find your name and sign. Don't sign for your friends, okay? Tell your friends I won't sign for you. And then ask your friend to email me if they have any problem. Talk to me, okay? Please talk to me. Don't do things yourself, okay? And then we will figure out how to help you, or I can just record. Okay? Tell your friend you won't help him, okay? Don't lose it, must pass back to me, otherwise I don't have a copy, I can't prove you are here. All the class will go on the attendance. What else? Okay, maybe five, maybe 10 minutes, 3 minutes. You want to try contradiction or not? Yes? Okay, maybe this time I let you do it. Or you need to tell me what, tell me what to do, okay? I don't know how to prove. Tell me how to do, okay? It's a contradiction. 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 Okay, tell me how to do. What do I need to know first? What do I need to know first? What am I proving? I need to prove the proposition is? Okay, it's a contradiction, and then by definition, I need to prove that it is false no matter what, always false. Okay, it's not just false, it's always false. That means no matter what variable I pick, what possibility I pick, the result is false always. Okay, so this column only can appear what? False, all false. Okay, so let us try. So similarly, we put how many possibility for P? 2, either true or false. Okay, and then not P already determined by P. Okay, so it's false because when P is true, not P is false. When P is false, not P is true. So true P and false not P. What do you get? N. True and false. False. False and true. False. Okay. So it's false. Yeah. So all false. So this is how you prove something is contradiction. So maybe in the assignment I can put like some longer stuff, right? And then you should prove that something is contradiction or so how long is this row, right? Depends on how many variable here. Okay, because you need to include all the possibility, right? So for example, maybe you don't know what I'm talking about. So P, Q, R, how many possibility? 2 times 2 times 2, right? Correct? So it's 8. So you should have 8 rows. Right? For example, you got true, 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 false, true, false, true, something like that. Okay, keep going. Okay. What else? What time is it? Okay, any more question? No more question. You should sign the attendance sheet, and then we will go into break, and then we come back for the last hour tutorial. Okay.
To ask what's the meaning of zero?
Oh, yeah. Okay.
Why it can be zero?
Why can't be zero? It's just empty. Nothing. Yeah. So this is length of 1. And empty string. And empty string. No bits.
It's empty, but it's a string.
Yeah. Yeah. So maybe because we can like combine this 2 string maybe by what notation, but maybe we can put this 2 string together. So we can combine length 6 string. You get what I mean? So you can combine the string. So if you combine with an empty string, you get back yourself. Yeah. Okay.
Okay.
Yeah. Although I'm not sure whether you use combine or not, but I mean, yeah, that's what I meant. The operation. If you combine the string together. Yeah, so if you combine with empty string, then you get back this. You get me? So if you combine this the empty string,
It's still this.
it's still this, yeah. Yeah. That's right. Yeah, that's right. So right. So length of this plus length of this is still 3, right?
Yeah.
Yeah. So it's still yeah. What is qubit? What is qubit? Oh, what's qubit? I mean, qubit for quantum picture and comprise from 1 to 9. So I think the way they get 1 to 9 is when they add the 1 7. So that's nice. It should be 9. So they can process a lot of things. So that's why supercomputer, the quantum. What? What picture?
That is the QR. This what is it?
Oh, what is this?
Yeah.
So I mean, because in this proposition we only talk about P. So maybe there's some something like that. So I need to and you okay. So to combine all the possibility, to consider all the possibility, you count all the possible where which is true, right? Ah. Okay. I mean
That's the 8.
for this case.
Oh, for it.
Yeah, for this case. If you have more, you say you have more, then you need to like yeah.
Oh, okay.
Yeah. This is how you found the order possibility. Right?
Yeah.
Wait, let me. Yeah, 不想说英文，不要这样说英文。对，写一下，对吧？
这个是什么意思？
哦，OK， just now I explained to them. So, for example, you have this case. So, you want to check out the value of this combination, right? Okay, right. So, you need to consider every combination. So every combination has two possibilities. Right. And then to calculate all the probabilities, for example,
对，就是每个面有两种情况，
how many possibilities?
要么 true，要么 false。
Or
就是如果是让 P 和非 P 的话，
why are they
只要
false?
看 P 就好
Because true
，P 被 P 就好。
or right? So if you got 3, then 2. If you got more than yes. Combination. Yes, combination. Yes. That's right. That's right.
我问
喂，
你可以调一下空调吗？有点
可以了。OK，没有你自己调。OK。 Yeah. Just use the normal convention then, which is 0 is false, 1 is true. Because when you use this, right? Because when you use this, sometimes there's a confusion, which maybe sometimes people take 0 as true, 1. You get what I mean? You can swap. Right. So this is the convention I pick. If you're using the same convention, then you can. But if you like swap, then it's very hard for us to check your answers. So yeah, if you use this, then you can. If you follow this convention, then you can. But normally, to avoid confusion, if we say that just do the truth table, then we do this, easier to check. Yeah. But if you use the convention, the same convention should be. Yes. Okay. Where's the attendance sheet? Attendance sheets now? At the back there. Already passed to this line already done? Huh? Haven't? Or that person haven't? Okay, wait for. At 6 o'clock, someone haven't come back, right? Is it? You can see from Moodle, I already proposed the tutorial question. The ideal situation is you try at home, not necessarily finish it, but just try, and then you can come, and then I will give you about 10 to 15 minutes. You can discuss with your friends, maybe 4 of you or 3 of you, up to you. And then when there's a quiz week, then this time will become a quiz time. Okay. Other time, then you can discuss with your friends, and then we will discuss together after 10 or 15 minutes. Okay. Yeah. Any question? Oh, just now some of you like confused with this PQR thing, right? Can everyone see it? Can everyone see it? See this? Can everyone see this? Can? On the back? Okay. So when I talk about this PQR, right, I mean when the proposition, it might have more variable in here. Okay. So each variable will take different value. So what I'm suggesting, this 2 times 2 times 2 for this case is how many combination you will get. How many total combination you get. Okay, for example, in the 2 case, you get true, 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 false, false, true, true, true. Why are they for? Because it's 2 and 2. And then in this case, you have true, 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 and then this is what I'm listing up. And then in total, you get, okay, wait. So in total, you get 2 times 2 times. should have 8 of them to check whether it's complete or not, right? Because to show that something is contradiction topology, you need to check all the possibilities. Okay. So if you got 4, then multiply 4 times. Where's the attendance sheet now? Okay, this row. Make sure each one of you sign it before you leave this class. Okay, now anyone do it at home? Yeah. Anyone see the Moodle? Did you see the tutorial question on the Moodle? If you you got okay. Maybe I will do it that way next week as well. Unless I get questions from different places, then I will have it. Otherwise, just try this. Okay. And I can tell you the answer is not in the textbook. Textbook only got odd number question, odd number answer. Yeah, try the question. Yeah, now. And then we will discuss together at 6:20, 6:15 or 6:20 like that. 6:20. Can I ask for your class, right? Do you typically have classes on Wednesday, Thursday, 12 to 2 p.m.? Oh, no, right? Okay. No, maybe I just say it this way. Maybe I'll check with another 2 class again. Another choice I was thinking was like Tuesday before the class is like I think for what's 4 hours. 1, 2, 3, 4. 1, 2, 3, 4. So it's like 12 p.m. to 4 p.m. This time, are you guys? Do you have any class? Tuesday, 12 to 4 p.m. This is a second choice. This or this. Tuesday. Any clashes? No? So this is my first choice. This is my second choice, maybe. Both can? Both true? Or one true, one false? Huh? Both true. Both can? No? What? This is my first choice. This is my second choice. Huh? First choice better? So first, second choice, you guys got class, is it? What time to what time? Or 12 to 2. Then you can come 2 to 4. Right? Huh? So I mean, if you have class from 12 to 2, you still can come 2 to 4. Yeah. Okay? Both can? Okay, I will see. Anything I will update in the course information and then I will do announcement on Moodle. Yeah, pass to the. Hey, is my clip gone? Where's my clip? Paper clip. Yep. Oh, can you email me and then I'll add you in. Email me. Yeah. Email me your student ID again if you can't go into the Moodle. Because I think I got 19 students still cannot be enrolled because the student ID is not in the system. Email me, either I enroll you or I will give you the enrollment key. For now, I already put it on the wall. Yeah, should be by next week. I will enroll everyone successfully enroll everyone into the Moodle by next week. Are you all first year? First years? First years, huh? Okay. I'm first years also. So we both have to work hard. So don't fail this course. Don't want to see you again. Okay. Yeah, so work hard starting now. Okay. Don't wait. Make sure you understand. If you accumulate, then there's a lot of things to revise. I'll find a name. Yeah. Yeah. Oh yeah, since I got 3 cars, right? So maybe my lecture note will be posted out after Thursday. Okay, Thursday. Okay, we start discussing in 5 minutes. Okay, let's keep going. So, okay, email me if you can't, if you are not in Moodle, okay? So one quick question, is this a proposition? Huh? So it's a if, then, right? Is this a proposition? Huh? Yes or no? No. So this is not true or false, right? This is a command. Okay. This is a proposition. Okay. Okay. Not proposition. Email me, okay? Make sure you email me with your student ID so that I can add your number. If not, I will pass you the enrollment fee. Okay, good. Okay, real business. So which are these proposition? What are the true values of those that are propositions? So do not pass go. Oh, this is like monopoly. So do not pass go. Proposition or not? Huh? Who say? Say again. Yes or no? Why no? Why no? Why no? No, this is a command. It's not a true or false statement. Okay. What is true? Do not pass go. What is false? Okay. What time is it? Not true, not false. Cannot true, cannot false. Okay. There are no black flies in my knee. I don't know what is this. Yes or false? No, no, wait. I mean, what is it a proposition? Yes. Okay. You can say whether it's true or false. Okay. 4 plus x equal to 5. Proposition or not? No. Why? Huh? Why? It's not what? It's not a statement. Why is it not a statement? It is a wait. So wait. So proposition and statement is the same, okay? It's not a statement, it's not a proposition. Why? It's not a sentence. It's not a sentence. Rather than saying that it's not a sentence, actually this sentence is not complete. Okay, because you didn't tell me what is X. I don't know what is X. I can put anything in. I don't know how to answer you. Okay. So I cannot say true or false. Depend on your X. If the X is 1, that is correct. If the X is 5, that is false. Okay, depend on what X you put in. Okay, why you look confused? Are you okay? You okay? Okay. Okay. E. The moon is made of green cheese. Is this a proposition? Yes. Okay, true or false? Yes. Okay. And how you know it's not green cheese? How you know? Okay, maybe it's white cheese because it look white. Okay. Cheese, I don't know. Okay. F. 2 to the power n is greater than equal to 100. Why is it not a proposition? Huh? Why? Why? Huh? Why? Not what? Cannot hear. Not complete. Okay. Because it doesn't tell me what n is. So when what n is true for this? Can you find the n for me? Can you find what n for me when this statement is true? 27. 7. Okay. 2 to the 7 is what? Oh, very fast. 128? Seriously? Okay, yeah, correct. Okay, very good. Okay. So this symbol stands for is greater than or equal to. Okay. So you will see that although it's not equal to, but it's still greater than, right? So or whether either one of them is true. Okay. Very good. Any question on question 2? No questions? Okay. So what is the negation of this following proposition? Janice has more Facebook friends than Jen. Yuan or Jen? Yuan. Maybe yuan better. Huh? What's the negation? It is not the case that Janice has more Facebook friends than Yuan, which means Yuan has less than or equal friends than Yuan. Wait, let me put it up. Or Janice does not have more Facebook friends than Yuan. Any other question? Any other different answer on this? You can say yours. Any different ones? Any interesting different ones? Nothing. Okay, how about next one? Quincy is smarter than Venkat. Quincy is not smarter than Venkat. I don't want to use stupid. Okay, we just keep it here. Okay, C. Zelda drive more miles to school than Paula. So Zelda does not drive more miles to school than Paula. Okay. If you have different one, you should say now. Brianna sleeps longer than Gloria. So Brianna doesn't sleep longer than Gloria. And then Brianna sleep less than or equal to Gloria. Or Gloria sleep longer or equal to Brianna. Okay. 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 Okay, where's the attendance sheets now? Where's the attendance sheet? Done or done? Okay, up to you. There should be a paper clips with it or two of them. I don't know where is it now. Gone already. Paper clips. If you see paper clips, please pass back to me. Supposed to have a paper clip, right? Okay, next. Okay, this is a good one. So let T and Q be the propositions. I bought a lottery ticket this week. I won the $1 million jackpot. Okay, let's do not P. Why is not P? I didn't buy a lottery ticket this week. Very good, good boy. Didn't buy. Okay, next one. Wait, who want to say it? Say it loud. One of you. From here, from this table. You say? Huh? Okay, you say? Yeah. You. B. B. Yeah, you. B. What's B? Mm-hmm. 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 Ah, but you didn't win. B or P or Q. Don't say the fact already. Okay. Huh? Yeah, oh, I won. Yeah. Okay. Don't tell us your true story, okay? So either I bought a lottery ticket this week or I won the $1 million jackpot. See? See? Yeah, maybe you just keep going. Yeah, you. Yeah. Yeah, very good. If you buy, then you win it. Okay. Next, the back one. Continue. Yeah, continue. Oh, you're lucky. Very good. Okay, next one. Next one. Yeah, very good. If you want to win, you must buy this way. Okay. So if you want to win, you must buy this week. Okay. Next week cannot work. Only this week. Next. Wait, F. Say again. F. F. Okay, good. If you didn't buy, then you didn't want. Okay. G next. Right. You didn't buy, so you didn't win. That's right. Next. Oh, this one.
Or I bought a lottery ticket this week and I won $1 million.
Okay, very good. Yeah. That's right. Why come back to the front? Okay. Okay, everyone got it? Too small to see. Too small to see. I'll put it on Thursday. Can you see it now? Which one can't see? Too small, is it? Too many words. Okay, I put the F down a bit. Actually, not much different. Either I just put either or if I didn't, or negate, or everything else is just copying. Okay. No question, then we proceed. Proceed. 10, 20 minutes. Proceed. Okay. Determine whether each of these conditional statement is true or false. If 1 + 1 equal to 3, then unicorns exist. True or false? False? Why false? Why false? Unicorn doesn't exist, or right? That's right. 1 + 1 equals to 3 or not? No. Okay, no, it doesn't. So false implies false. True or false? True. So this is true. Okay. This is true. So actually, right, in mathematics, right, actually this question shouldn't exist first. Okay, because I haven't tell you what is 1, and I don't tell you what is 3. I don't tell you what is plus. I don't tell you what is equal. So in this book, they just assume you to know what is 1 + 1 equal to 3. Okay. So in the proper foundation of maths, also logic, we have to introduce you what is 1, 2, 3, 4, 5, 6, and then I have to introduce what is plus, equal. Then we can start to talk about 1 + 1 equal to 3. Okay, but anyway, in this course, we just assume you know first. Later, we will come back to calculation again. Okay. Okay, so this is true, not false. So if 1 + 1 equal to 3, then dogs can fly. Very good. So dogs can fly or not? No. So false. 1 + 1 equal to 3 or not? False. Why 1 + 1 equal to 3 is false? 1 + 1 equal to 1. No, this is not a trick question. I'm just asking you. 1 + 1 is what? 2. Okay. So false implies false is true. Okay. How about next one? If 1 + 1 equal to 2, then dogs can fly. False. Why? Tell me a reason why. True implies false. True implies false is false. Very good. This question didn't give true, false implies true. Never mind, I already tell you in the lecture, okay? So if 2 + 2 equals 4, then 1 + 3 is 3. True or false? True, very true, very true. Very true, okay? It's too true to be true. Okay. Next, state the converse, contrapositive, and inverse of each statement. If it snows tonight, then I will stay at home. Okay, I want to start a row again. Start from this for you. Say it out loud. What's the converse of this statement? Huh? Yeah. Okay, can you hear from the back? From the back, can you hear or not? Can you hear? Cannot? Louder. Please, sorry. Then it will snow tonight. Okay? Can you hear? Okay. Next, what's the contrapositive? Hmm. Maybe you can say, if I do not stay at home, then it wouldn't snow tonight. It won't snow tonight. If I do not stay at home, then it won't snow tonight. So the wheel will keep on at the back as well. You get what I mean? The wheel. Okay, I write down. So see here. Normally the wheel will be at the back. So if I do not stay at home, then you won't snow tonight. So if you don't stay at home, then tonight it won't snow. Okay. Okay, next. Yep. Can anything? What? Yeah, if it doesn't continue. You wouldn't what? Wouldn't skip. Wouldn't skip. Why your question is different from me? From mine. And then your snow is today, not tonight. Mine is tonight. If it doesn't snow tonight, then I won't stay at home. Why you got ski on? Oh, your ski. Huh? You wouldn't stay at home, but you want to go to ski. Okay, that's good. Good for B. Okay, next question, B. Part B. What's the converse? I think this is the same as B. So remember the whenever is the if. So let me draw it out. So this is the if I got it right, then it's a sunny summer day. Yes. Okay. So how you see this? This is like a if. Okay, so this is the P. This is the Q. I didn't write this out, so make sure you listen carefully to what they say, okay? If you can't ask to repeat again, raise your hand. So I repeat again, the converse of this is if I go to the beach, then it is a sunny summer day. Or it is a sunny summer day whenever I go to the beach. Wow, very good. Whenever you go to the beach, it's a sunny summer day. Okay, next. What's the contrapositive? Next. Yeah. They will that it will okay, then it is not a sunny summer day. Okay. It isn't a sunny summer day. Okay. You need me to write up or not? Next. Next. I will not go to the beach. No. Wait, you see? where is your if P and Q? So let me write down if P, Q. So inverse is what? Yes. Okay. If it's not a sunny summer day, you better don't go to the beach. Okay. So this is a trick here, okay? Make sure you know this whenever. If you keep doing it wrong, maybe it will appear in the quiz, okay? Whenever. Okay? Okay, next. Okay, I start from and maybe continue then. Continue. Okay, so you say that this is the P. This is the wait. So you say that this is the P. So you should see me how I process this thing, okay? So this is the P, this is the Q. So you say that this is if P, then Q. Okay, let me check first, okay? It is necessary. So necessary, what did I say just now? So necessary should be the thing at the back. Okay, so it's the Q thing. So I transform this sentence to something that I know is this is should be the Q. Should be the Q, should be the P. So I transform to something I know is if I stay up late, then I sleep until the converse is if I sleep until noon, then I stay up late. Is that what you said? Okay. Next. Yeah. Okay, good. Next. Next. Any one of you? Please shout, I can hear later. Any one of you? Doesn't have the exercise? None of you have? Yeah, okay. If you don't stay out there, you must sleep until noon. You don't stay until noon. Okay, good. Okay, any other questions? No? What time is it? See what time, Okay, 7 more minutes. Okay, so maybe, hey, you don't have the question, can't you share with your tables, like your classmate? Can you share with her the question? Yeah. Yeah, share, help each other. Help each other. Okay, 48A. Maybe here, starting from this row. Just tell me the end answer first. What do you get? What bit you get? 48A. Haven't finished. You? What? You haven't finished too? Okay. You also haven't finished. Wow, what you guys did just now. Next one. Haven't finished? Don't know how to do or what? Oh, not enough time. Huh? Okay. Anyone from this table finish this question? No, none of you. That table? That table? Try. Got answer or not? 48A. If you want to do on the spot also can. Just tell me the answer first. 48A. Okay, very good. 11000. How do you get the answer? Okay, very good. 11000. So you do the O first, and then you do the N. Okay. Next, B. 0, 1, 1, 0, 1. Wow, very good. Faster than computer. Okay. So you do the N first, and then you do the O. Okay. C. 1, 1, 0, 0, 1. Okay, good. Same as mine. Okay, very good. Next. Next. 1, 1, 0, 1, 1. Okay, good. Okay, check your answer and then see whether you understand or not. You can ask question, or you already do start doing other question. You also can ask question. Any question? Any question on today's tutorial and today's lecture? No. Quick! You must give me one question. I give you 6 questions. You must give me 1 question, okay? Before you go. You wanna ask? No. Quick, ask me 1 question. 4 minutes. Then next time I have to prepare more questions for you if you don't want to ask me question again. Huh? Has to be meaningful. No, what do you mean by meaningful first? Define meaningful. Say. No, just in your own word. Huh? Yeah, so your proposition should be enough for you to say, meaningful enough for you to say, to determine whether it's true or false, or in other words, it's maybe falsifiable. If you heard this word before, you can whether prove it is false or prove it is right. You can say it's true or it's false. Whether or not it can be proved or not is another story, but whether or not you can say it is true or false. Okay. The most important thing is you can say it is true or false. Obviously, a question is not a true and false. Okay. And then just now what we say is command. Command is not true or false. There's no true or false. So like in the military, so you can't really ask your boss whether it's true or false. You just need to follow. Okay, whether it's false, you also need to follow. Okay, so this is the practice. Any more questions? 3 more minutes. I cannot put you off earlier. Later they'll get me this link. Quick, 1 more question. Huh? What is on the quiz? What is on the quiz? Yeah, okay. X or R? Okay. What do you want me to say about it? You mean why is it the n truth? Why is it false true true false? Or recognize? You don't know how to recognize. You don't know how to recognize it. So okay, one way to memorize this. Okay, first the question say why is it like this? The answer is because I define like this. Okay. Second, you should ask why I define like this. Okay. So I give you an example. There's a real situation here. So your stomach is only enough for a chicken rice or an economic rice. You can't have both together. Okay. So if you have both together, then you are false already. You might get sick. Okay. Yes. P S O R Q S O R. Okay, good. So if you want to do this truth table, right? Very good. Okay, this question touches on algebra of logic, which we will deal with it next class. Okay, so because you can process it like two ways to process it. You can process it this way. You also can process it this way. Okay, meaning you can do the back one first and then do the whole thing, or do the front one first and then do the back do the whole thing. Sorry. So actually you can prove that. I think if I'm not wrong, these are equivalent. These are equivalent. So they are equivalent. So they are the same. So whether or not you do it Q and R first and then do the whole thing, or you do PQ first and do the R thing, is equivalence. And then I will teach you how to show their equivalence next class. Okay. So this is a good observation. This is called a distributivity. Okay, this is algebra. Okay, no more questions. See you next week. Okay, thank you. Bye. Oh, you're not inside. Okay, maybe you should write. I mean, you should write, and then you can send me. Okay. You write it here, and then next time you just like. Okay, so write it nicely. Yeah. Because the system didn't update yet. And you should send me an email, okay?
Okay.
Then later I need to check your.